the game. And you ask what the title of this is?
What's the title?
Yes, thank you for asking. Percent change. Let's go with dimensions, not dementia, because that's a whole different thing, but probably applicable as well. Dimensions. And it is percent of change. And it's probably at this point that I should forewarn you, if you're one of those people that likes not to think about math, this will not make any sense to you. In other words, how many of you just read the problem, you see a bunch of numbers, and then you throw it all together and say, that's my answer? Be honest with me, because some of you do that. You don't actually look and say, does this make sense to me? If you have to, this is, and I can't change it for you. I mean, I know some people don't like math, some people love math, I mean, whatever, but I can't make you force yourself to actually think about, does my answer make sense? Which some of you, when you read your answers, it makes no sense. I don't know how you could have read the problem and got the answer, because it's like, for example, I don't know where it was, but a $50 pair of shoes on sale for 30% off, and you get $75 for your answer. I don't know how you could have read the problem and thought about it and said that's even. Fisher, does this make any sense to you? Just say no. No. Okay. Here we go. I just want you to think about this. Let's write this down. One square is 50% larger than another square. One square is 50% larger than another square. By the way, say hi to the rest of the class that's not here, because they'll probably have to watch this, because I am not. I refuse to talk about this again. Say it by name. Everybody by name. Hi. Okay, stop. Enough with that. Here is the thought then. Okay, what does it mean for a square to be 50% larger than another square? First of all, Shannon Bivens, does it tell you how big the square is? No, which should make you happy, because if it doesn't tell you how big the square is, you get to make your own square when you think about it. Which means, Emily, if you get to make your own square, make it an easy to find answer square. Now you might think the easiest square to find the answer to is 1, but I wouldn't go there. I would go with 10. 10 is usually a pretty decent guess for a good number, because 10 is an easy number to work with. So let's just say, and humor me with this, I started off with a square that is a 10 by 10 square. Now, 10 what's, you ask?
10 what?
What unit of measurement do we want to use?
Inches.
Inches. Why? Because it's easy to make those two little dash marks. You don't have to really write it. It's quickest, right? It doesn't matter. They don't tell you it doesn't matter. So here's my square. It's a 10 by 10 square. So, Zach says, so what? Now, if I want to make it 50% bigger, what does that mean? If it starts out being 10 inches as a dimension, what is 50% larger than 10 inches? And don't tell me 5, because that doesn't make any sense. How could 5 be 50% larger than 10? How many people were thinking 5? Was anybody thinking 5? But that doesn't make sense, does it? When something says something is larger, you have to find out what percent it is and add it to that. So how big is my new square? Claus, you know the answer. What's 50% larger than 10? What's 50% of 10? So what's 50% larger than 10? That's 100% larger. 15. 50% of 10 is 5, and that's how much you're adding, because it's that much bigger. 50% bigger. Just like if you weighed 5 pounds more, you're 5 pounds bigger, you're adding that on. So what's my new square, by the way? 15 by 15. Is it just me talking to me? By the way, it's sunny. Not warm, but sunny. Okay. Then this is where Zach's going to say, what does Zach say? What you're thinking? Huh? Oh. Anybody wonder where this is going?
No.
Anybody care where this is going?
Yes.
Yes.
Yeah, we
do.
do. What are you talking about? Yeah, we do.
Alright, well, this is going here, okay, because this is actually a problem that comes in the book. Here is, I had us do this first because they're going to ask you a couple questions about this. This is box number 1. This is box number 2. Question number 1, letter A, if you will. See if this makes sense. The perimeter of the larger square is what percent of the perimeter of the smaller square? The perimeter, oh boy. The perimeter of the larger square is what percent of the perimeter of the smaller square? Of the, oh boy. By the way, I am going to try and make this the world record in the longest math video I've ever made. And you could be part of that. That should make you both happy and sad. Happy, why? You probably won't have much homework. Sad because you have to sit here and listen.
Yeah.
No.
No,
Sad because you're
happy
involved.
right here. We're happy right here.
Now, how many people got lost in this little statement here just because it seems like there's just a lot of words? Fisher, all they're asking you for is a percent. And what is our percent? I just want to know the perimeter is what percent, the percent of the bigger square is what percent of the smaller square. Now, before you start chucking numbers in there, Zachary, think about how can you find, what are you looking for when you're looking, first of all, you're looking for the perimeters, right? You're looking for the perimeter of the large square is what percent of the perimeter of the small square. Which this gives you a fraction, but hopefully by 7th grade now you can turn fractions into percentages. Maybe you can, maybe you can't. But this is your answer. Perimeter of the larger square to the smaller square. Now, they could have asked it the other way around, that the smaller square is what percent of the larger, but they didn't. They said the perimeter of the larger. The larger was given first, which I didn't even write down, did I?
No, you did.
What? Oh, there it is. The large square is what percent of the perimeter of the small square. Okay, so here we go. Let's figure out what is the perimeter of the large square?
60.
Love it. What's the perimeter of the small square?
40.
40.
And we cut it off. I took 6.
And then Zach says, yeah, I get 6 over 4, I get 3 over 2, I'm still not in percentage range. Anybody gonna tell me what 3/2 is? What is a percent? 3 over 2 is what number over 100? How about that way? Wow, we are in trouble.
150.
Yeah. Multiply by 50 is 150. So what's the answer to question letter A? 150%. To which you should say, that makes sense. Go ahead and say that.
That makes sense.
Because the square you started off with was 100%, and what percent did I add to it? Therefore giving me 150%. How about that? Okay, now that you've got the easy part done, Lauren. Zach, are you just repeating everything I say?
Zach, don't make him mad.
I know, it's a terrible thing to do. All right. Here, there are certain things in math that should frighten you when you hear. This next thing that we're going to talk about should frighten you enough to think about. This doesn't always make sense, and I've talked about it before. Question letter B. Question B, we're going to ask about this same thing. Write down this question. This is not intuitive, which means it doesn't make sense usually until you think about it for a little while. Which means your first thought is probably wrong, which is kind of like original sin, Zach. Your first reaction to everything is usually the wrong reaction, right, Caleb? For example, when I give you an assignment, your first thought is, I don't feel like doing it. That's the wrong thing. Or when your brother smacks you in the head, your first reaction is to, I want to hit him back. Wrong one again. That's all. It's all natural sin. You don't have to be taught to be. You don't have to be taught to be bad. That comes naturally. You have to be taught to be good. Is that true or not? That's this one. You could. Amen.
Amen.
Here we go. Here we go. Ready? This is it. The area of the larger square is what percent of the area of smaller square? Now, intuitively, you would say it's 150%.
Wow.
Unfortunately, that is incorrect. Okay, and here's how we prove that. Okay, perimeter, it's right, because perimeter is a measurement of distance. It's a linear measurement where you just line these up and add them together. Area is not a linear measurement. Area is gained by multiplying two things together, and that's what throws things for a loop. But let's go back to this. So just like this, I'm not looking for perimeter, but now I'm looking for the area of the larger over the area of the smaller. And there was a good reason. It was good of us to pick 10 for our square there, because area of those squared. Well, let's go. Area, give me a color. I don't want blue. I want Let's look at area of the smaller square. Should be pretty simple. Area of the smaller square is, Joseph?
100.
Joseph, thank you. 100 inches squared. The area of the big square, I'm not sure most of you can do this, but anybody know 15 times 15? Cassandra, 15 times 15. Anybody got that committed to memory? You should know 15 squared. Anybody? Did you know it? Emily, what is it?
225.
It is 225. So if I put those numbers in here, the area of the larger square was 225. The area of the smaller square is 100. And I know this one's really going to throw you. What percent is 225 over 100? Andrew, I think even you can feel this one. I have 225 over 100. What percent is that? Now remember, percent means out of 100. So if I have 225 over 100, what percent would this be? Thank you very much. The answer to question letter B is 225%. Now that is not intuitive because, wait a minute, I started with 100% and I added 50% to it. Why didn't I get 150% there? It's because you kind of did, but you have to remember what happened here. Because I am multiplying, this number increased by 50%, as did this number, which means you increased it by 50% twice, which means you're going to get, somebody answer my phone. 225%. That is the part, when you talk about area, it doesn't always make sense intuitively. So you always have to sit back and think, is my answer right? Am I doing this right? And don't just jump on the bandwagon and say that's 150%. How about that? You ready? That, by the way, that was not the confusing part. Huh? Yeah, okay. Well, when you get things wrong, Lauren, you'll tell me. Ready? Here we go. Lauren says that's not confusing, so let's do this.
Wow.
And you can thank Lauren for me going here because the towel shrunk 10% when it was washed. The towel shrank. Is it shrank or shrunk? I don't know. The towel shrunk. What is it actually? It did say shrunk. The area of the towel was reduced by what percent? The area of the towel was reduced by what percent? 10%, isn't it? Why would they ask you this question? So that really is the answer. Exactly. Okay, you cannot, and again, when you're talking about area and percentages, you have to say something isn't right. I better make sure my answer is right. Okay? So here's what we're going to do. To find our answer, by the way, this is a percent decrease problem, right? So here's how I'm going to start this. I'm going to do my percent decrease box. Hip, hip, hooray. If I had candy, I'd give it to you. What does it look like? It looks like this. Okay? It looks like this. The original minus the decrease equals the final. And this is the actual area. Now, let me warn you on this, children. This is where it gets a little scary, and even Lauren may not understand this. This percent is not this percent. Okay? These two percents are not the same percentages. This is the percent of the area. This is a linear percent. They're not the same percentages, and we're not going to put 10% in the decrease here because we're looking for the decrease of our area. We're going to find this out. We can put 100 in here. That's okay, but we don't know this and we don't know this. We are going to figure it out by using this. Confusing?
Yes.
Okay. But I'm just telling you, it's not. Because otherwise our answer would have been 10%. Now we just put it there and everybody would be happy. So Zach says, again, they don't give us any dimensions for this thing. So you're going to pick, you get to pick your towel size. And you can pick anything you want, but I would suggest picking 10 and 10, just because. So here we go. Here is our towel. Zach, what kind of towel is this?
Green.
Okay, it's a hand towel. Should we put something on it? Who'd you pick to win the NCAA?
A face. Duke.
Okay, who didn't pick Duke?
Face.
Enough idle chit chat. So there's my starting towel. It was reduced by 10%, so my next one's going to be a little bit smaller. 10% is not that much. What are my new dimensions? What is 10% of 10? 10% of 10. Cassie? 1. So it's decreased by 1. You want me to do the math? Look. 10% times 1. That's 10%. I just took the 0 away from it. You get 10 with the decimal worth 1. So my new dimensions are, it went down by 1. The new dimensions are 9 by 9.
Inches?
Yes. No, let's go feet because that's just
The
one
perfect hand.
mark there. Doesn't matter what your dimensions are. So here we go. Area of the first one, the original area was 10 times 10 is 100. That goes here. That's my original area. Look, 100 equals 100. This is going to be easy because I already know my scale factor.
1.
My new
81.
area,
9.
81. That by the way is my final area. How about that? To go from 100 to 81, how much did it go down?
19.
Guess what my decrease is? By the way, look, at these are the same. My scale factor is 1. It's 19. This is 81. The answer to this question, by how much when it was reduced by 10%, by how much was the error reduced? 19%. Did I get to the confusing part yet, Lauren?
Yes.
A little bit.
Once you did it,
Yeah,
once
Yeah.
you did it, put it in.
That one's a person.
At one point, were you mid to nine?
Emma?
I'm confused on why it's 19%, not 1%.
Wait, are you confused why this is 100% starting and ending 81?
No.
Because these two, when you subtract, because this is a decrease, 100 minus what number gives you 81? This is a decrease in percent, so those two subtracted have to give you this.
Okay.
So this plus this has to give you that when you're talking about it. Is anybody asking if there's an easy way to do this?
No.
Is there an easier way to do this?
There is, but it would confuse you, so we may not do it today. Plus, I'm trying to waste as much time as possible so you can sit here. Zachary!
I don't understand how you got from the point one.
That was my 10%. I just changed 10% to a decimal. I wanted, Zach, I needed to find 10%. 10% of 10. So I changed that to a decimal, 0.1 times 10, which is 1. Good question. I skipped a little bit there. All right, I'm ready. We are ready for something. Ready?
Yes.
Here we go. Write this one down. If the dimensions of a cube, are increased, wait till we get to this one, 100%. 100%. By what percent is the volume increased? By what percent is the volume increased? By the way, thanks for stopping by today.
You're welcome.
I really appreciate it. There's hope for seventh grade yet. I sense not quite as much dullness and listlessness. Once again, the person who looks at this goes, well, if it went up 100%, it should be 100%. Shouldn't it?
Yes, average person.
But you guys are not average anymore. Now, to note here is this. What type of problem is this? Before we even start, this is a, what percent increase? So you should start off before you do anything by going, okay, here it is. I am original, I am increasing, it's plus, and then I get a final number. And this is percent. And guess what I'm going to tell you? This 100% is not this 100%. Can't do it. Now, originally, it is 100% to begin with, just because everything is 100% when it starts. We know none of the rest of these until we actually sit down and actually try to figure this out. Does anybody have a guess, by the way?
Let's sit down and try.
Does anybody have a guess? Does anybody guess anything? No, Lauren, close your book.
Lauren.
I'm open.
What kind of
It's
deceitful
rude.
people are you?
I'm not really.
Now, just for fun, Chase, what are you doing? After I told Lauren not to do such things. Here we go.
Andrew.
Wait, what did Andrew do?
He made Chase open his book.
Chase, I want you to pick the dimensions of my cube, and I don't want you to pick 10 this time, just to show that it can be done without tens. Huh?
7.
7, really? Fine.
Really?
Now, it's important before we start, where will my answer be in here? Where is my answer? Which one of these is going to be my answer? I want to know by what percent is the volume increased.
Increase.
This one, this is my answer. When I get to this point, this is my answer. It's not the final percentage. By the way, final, yeah, this is this box. Okay, so here we go. Chase, you did this here. If I increase this cube by 100%, what will be my new dimensions? By the way, you're the one that had to pick the goofy numbers. If you increase 7 by 100%, what's your new dimensions?
700. Oh, no, it's not 17.
What is 100% of 7?
7.
So if you increase 7 by that, you get 14. 100, increase it by, so basically you're making it, the dimensions get doubled because you're adding 100% to it. 100% of 7 is 7. I'm increasing it by 7. So now my new cube is, this is Chase's fault, 14 by 14 by 14. Good luck with this, Chase. So here we go. I can figure this out now. Here is, my original volume is 7 times 7 times 7, which everybody knows is 49 times 7 is what? 63, 6, 28, 243. Oh, Chase. Look at, there's my scale factor, by the way. How about that? 100. What do I multiply 100 by to get that? 3.43 apparently, huh? What is the volume of this one? 14 times 14 times 14, huh?
Because
what?
of the mathematician. Yeah, no.
What? I did the math. I didn't know that was
No.
343.
The 100 to 343. Because he's a
Well,
math.
because it's, if you move the decimal 2 places back on this, because you're just dividing that by that, you get 3.43. That one's not a hard one. I would take that. I'm going to get my calculator out because I really don't. Although, now let's do it just because. But if I expect you to do it, why not? What's 14 times 14? Did anybody do that? What? 196. And 196 times 14. 24, 236, 38, 4, 7, 2. Nice. 2,744. Thank you, Chase.
Wow, Chase.
We want off Taylor.
Yeah, please. He's no longer driving.
Sorry,
Wait,
kid,
was he
you
driving?
Like, you messed up, kid. You.
Chase, I can't believe you did this.
Look what you did. Look what you made me do.
Wait, did I do that math right? Did somebody do that?
Yeah, it's right.
Okay. So, to figure out what this is right here, you got to subtract, right? Those two have to add up to this. So 2, 7, 4, 4, minus 3, 4, 3, 1, 0, 4, 2, 2, 4, 0, 1. Now blame this on Chase, because now we have to do the actual calculations of what this is here. Chase, you're killing us.
Andrew didn't do this one. This is all Chase.
I don't know. Okay. So we're down to this proportion here, 100 over what number? 100 over what number is 343 over 2401.
Oh my gosh.
It's okay, Chase.
Chase,
Chase,
well,
have Chase do the math.
Chase can figure it.
Actually, I'll do it.
No.
We are hoping, against hope, that somehow something goes into one of these.
I don't think so.
Oh,
He's
God.
hesitant. Whoa, he's hesitant.
I don't know.
Let's try this. Hold on. Let's back the system off here. Let's see if we can't reduce this fraction. I'm going to hope, against hope, that we did something right, and 343 times 7 actually gives me this number here. 21, 2, 28, 33, 21. Oh, how about that? So this fraction actually reduces to
I just did one.
1 over 7.
Whoa.
That's a lot.
So, what is my answer? Cross multiplying n times 1. 1 n equals 100 times 7. And guess what number goes up here? 700. Thank you, Chase, for making this way more
Chase is
complicated.
never
Why
allowed
couldn't
to.
you
Chase
like
never
never
allowed
allowed
to
to make any numbers angry?
And
That's a 20.
your final your final percent, if you actually were asked for that, 100 plus 700 is 800% bigger. 800% bigger.
Oh my gosh.
Hey.
Confused?
Yeah.
Still bad.
Right, you
It's
confused
not like
me.
that hard. Yeah.
Now, Connor Morgan, if you got confused on the math, blame Chase, because this would have been like, if you would have picked, if you would have picked here, watch how fast this would have worked. Had Chase, here we go, hold on. Watch. It had Chase picked just his cube to be, sorry. No, let's just go with 1. I want something that's easy to work with. Had Chase picked his cube to be a 1 by 1 by 1 cube. And the new cube increased by 100% would be a 2 by 2 by 2 cube, right? You're just adding it to itself. 2 by 2 by 2. If you're looking at these percentages over here, erase these. Watch how fast this would have been. All right, Connor, this was still 100%. I don't know what the increase is. I don't know what any of these numbers are, but I do know this. Here's my area, my volume. I do know the original volume was 1 times 1 times 1, which is 1. I do know my final volume was 2, 2, 2, 8. So this number had to be 7. How do I go from 1 to 100? I multiply by 100, multiply by 100, multiply by 100.
It's not that hard. Just
That's why you